Okay, now we gave you an example of a problem moment in 2D. Okay, we solve this problem by using scalar method. Okay, here we have a beam with three forces. Okay, F1 at 375 Newton, F2 400 Newton, and F3 160 Newton. Okay, the first force we have downward force, and the second force we have at the angle at 345 angles, and the third force at 30 degree. So what is the first step to solve and to define, okay, the magnitude or the amount of the moment, okay, applied at the beam? Okay, first we have to resolve, okay, each forces, okay, into x and y direction. Okay, if we will draw back again, okay, the beam, okay, with its forces here, okay, the first force, the second force, and the third force, okay. So we need to define, okay, for the first force we have to have problem, we have directly in S direction, in Y direction at 375 Newton. The second force we need to resolve to Y and to X component, where the X component, the second force is 3 over 5 times 500 Newton, and the Y component is 4 over 5 500 Newton. Okay, and then the third force at angle of 30 degree here, okay, we need to define the forces in S direction and the forces at Y direction. Here we have the forces in X direction is 160 Newton sines 30 degree, and Y component is 160 Newton cosine 30 degree. So here, okay, from three forces, we have now 1, 2, 3, 4, 5 forces acting on this beam. Okay. Next, from these forces, we need to calculate, okay, or to define the amount of the moment, okay, acting on this beam at point, let's say if the question asks at a point A, okay, here, so the moment at point A, okay, if we take counterclockwise positive, okay, is equal to, so we take one by one. First is 375 Newton. So 375 meter times what is the perpendicular distance between these forces and this point. Okay, perpendicular distance between these forces, this force line with A is 1.5 Newton. So then we decide which direction it rotates. Is it counterclockwise or is it clockwise or counterclockwise? So if A is the rotation axis, okay, the rotation point, so we look here, the force is going downward, so it going to rotate this beam in clockwise direction, so it become negative. All right, okay, net forces, we have the component 4 over 5 times 500 Newton. What is the perpendicular distance between this force and this point? So we can see here the perpendicular distance is 1.6 plus 1.2. Okay, and then what is the direction of this force, okay, imposed to the beam to rotate? Okay, if it is the rotation point, so this beam going to rotate clockwise, so this is going to be negative. And next force is 3 over 5 over 500, and then we see what is the perpendicular distance between this point and this force. Okay, if you look here, this force cross, okay, the action line of this force is crossing, okay, the point A. So the perpendicular distance of this force going to be 0. Okay, and then is 0, it doesn't matter, it's either positive or negative. And then the fourth force, we can take this one, 160 sines 30 degree. Okay, what is the perpendicular distance between this force and this point is going to be again 0, and then the final one is 460 cosine 30 degree. So what is the perpendicular distance between this force line and this, the point A here is the total of the length. Okay, this is the action line of this force, then this the perpendicular distance is going to be 1.5 plus 1.2 plus 1. What is the direction of the rotation? Again, is going to rotate clockwise, so going to be a negative. So here we have 1, 2, 3, 4, 5 forces. Okay, how to calculate the moment, and then we get the answers. If the answer we get the negative, okay, you calculate by yourself, and then at the end we know that the total amount of moment imposed to this beam is equal to negative something of the value here, and then we can do understand it's going to be rotate clockwise. So this is how we do the calculation, how to we calculate, okay, the amount of moment on a beam. Okay, thank you.